Hey guys, today we're going to continue looking at derivatives, and we're talking about equations of tangent lines today. So what they're going to do is they're going to give you a graph, and they're going to ask you for the equation of a tangent line at a point, or possibly where are their vertical tangent lines. So let's get started. We're going to start with number 1. So the first thing that I'm going to need to do is to find the slope of the tangent line at a point, at x equals 2. And originally, you probably would want to just try to take the derivative here, but we don't know the product rule yet, so we're going to go ahead and distribute this out, and we're going to find out that f of x is also equivalent to 3x squared minus 3x. Now, to find the derivative, we can just go ahead and use the power rule, and remember that means you take that exponent down and multiply it by the coefficient. So 6x, we subtract 1 from the exponent, so just x to the first, minus, this one just has a 1 in the front, so the coefficient will stay the same, and then all my x's go away because 1 minus 1 is 0. So there's my derivative, and because they're asking me for the derivative at a point, find the slope of the tangent line, I'm just going to go ahead and plug in 2 into my derivative equation. So I'd have 6 times 2 minus 3, which gives me 9. Okay, so that's basically what we've been doing. Now what they're going to ask us about though is to write the equation of this tangent line when x equals 2. So if I was to look at this beginning graph, it's some parabola, something like that, and what they care about is they want to know what is the equation of the tangent line right here. Well, all I know right now is that my slope of that line, the derivative, is 9 at that point. So what I need to figure out are a couple other pieces of information. And you probably saw this equation back in Algebra 1, but we have an equation called point-slope form. And what we need to do is fill in all the pieces. Again, so your m right here is just going to be the derivative at that point. So that's the slope of the tangent line. We're going to pick a y1 and an x1. The x1 is going to be given, and we've got to figure out what was the y value of the original graph. So the hardest part about this is to figure out what y1 is. You're going to need to plug in x into the original equation, and you can plug it into your distributed one, or you could plug it into the original. So I need to find out what f of 2 actually is. So I'd have 3 times 2 times 2 minus 1. 2 minus 1 is just 1, so f of 2 is equal to 6. So that graph was originally going through 2, 6. And now I can just plug in all of the pieces of information that I know. I have y minus y1 would have been 6. That's the y value at that point. The slope of my derivative, the slope of that tangent line is 9, x minus that given 2. Okay, so that's in point slope form. And occasionally they might leave your answer choices in here. You do need to remember though, there are a couple of other forms of linear equations. They might also ask you to put in slope-intercept form, so solve it for y. Or they might ask you to put it, in standard form, ax plus by equals c, where everything is on the same side of the equation and there aren't any more fractions. So just know how to move things around in your answer choices. But if you can get here, surely you can get from this point down to one of these other equations. Okay? The other thing they might ask you is to find vertical tangents of graphs. So when I'm looking for a vertical tangent, what that means is when I'm looking on my graph, my tangent line is a vux. It's an x equals line. It has an undefined slope. So where I really care about on these graphs is I want to know where is the derivative undefined. Okay, so what I'm looking for here is I need to know where can my graph not equal to. So the first thing I need to do is take the derivative of this equation. And remember, a square root is the same thing as saying something to the 1/2. And I'm actually going to cheat here for a second because we have something that's actually called the chain rule that you'll learn about next year, where you actually have to do a little bit more than this, but we can cheat on this one. And this is a certain case in which that I can just use the chain rule on this whole thing instead of worrying about other pieces. So what not the chain rule, the power rule, and this is my function. I don't know why I wrote f prime of x. Okay, so if I take my derivative here, I'm going to do the same thing that I've always done. I'm going to move my 1/2 to the front, and then I'm going to have this thing raised to the 1/2 minus 1, which is negative 1/2. Okay, and that's only because the inside the derivative is 1, just in case you were wondering. Okay, and so now I'm going to simplify this out a little bit. My derivative is actually, to make this look nice, remember 1/2 is a square root, and since it's negative, it goes in the bottom. So what I want to know here is, where is this graph undefined? What would make this graph undefined? What values are not in the domain? I know that's a lot of different ways to ask that, but they could ask you any of those ways. So basically what I know is that right here, I can't have a 0 in my denominator, and I can't have anything less than the square root of 0, because then I have an imaginary number. So all I have to do is take my denominator for this particular case, and I need that to be bigger than 0, or where does it equal to 0? And so I look here and I would say, cool, great, I would divide both sides by 2, square both sides, and I would get that x equals -2. And so if you think about the graph right here as well, this would be that square root graph that's shifted over, and it would actually be shifted over to the left. And if I looked right there, and if I tried to draw that tangent line, that would be a vertical line there. And if you notice, I didn't put less than, just because anything less than -2 was not in the original domain. So basically you find your derivative, then you go ahead and you figure out, where was this undefined? Where is my denominator equal to 0? Where can I not have this function be equal to? Okay, the last thing is kind of similar to something we did in limits, and they're going to ask you, does the curve have a tangent at x equals 2? Or they might ask you, is it differentiable at a certain value? And you notice this is a piecewise function. So the biggest thing we know about tangents is you can't have a tangent line at a sharp point or a sharp curve. So what you need to look for is, we're worried about either the picture of this graph, or what I can do is I can take the derivative of each piece of this and see if those two are going to be equivalent, kind of what we did with limits. So if I take the derivative of this top part, remember I can just use power rule since this is a polynomial, so I take my 2 down to the 1 and then -2. And then I'm going to take the derivative of the second part and just have a separate line for that. And so this one, the derivative is only 3. The slope of that line is just 3. So if I did the left side, right side thing again, and I plug in 2 into this, so I'd have f prime of 2. If I plug in 2 into the top part, I would have 2 times 2 is 4, minus 2 is 2. And then that bottom is 3 no matter what. And so if you notice here, this is not happy, this is sad news, because they're not equal to each other, which means that those slopes of those tangent lines were different at those 2 points. And so I couldn't take the derivative at that point because it was a sharp turn. And if you looked at the original graph, that's what you would see here. And so since both of my pieces are not equal at this point at 2, that means that no, the curve does not have a tangent at that point. Okay, and that's all I got for you. You just got to remember that point slope form and how to continue applying that power rule and finding derivatives.